lesson over domain and range. The last few lessons we've been looking at functions and how functions consist of domain and ranges. And if the domain repeats or if the x repeats, the domain's not a function. Each domain has to have a different range. So today we're going to continue that. Today we're going to determine the value of the domain and range with inequalities. It is going to be F-U-N, fun. So let's get started. And before I start teaching, I need to record this lesson or I will be doing this all for nothing. And a magical whiteboard appears in the office. So let's get going. Okay, I'm going to have to keep this zoomed out so you can see all of this. So I'm going to go through this and say what I'm writing down. Okay, the first thing we're going to do is define the domain and range. Okay, just real quickly, you remember your domain is your x and your range is your y, right? Okay, so the set of all possible, let's put input values. These are the numbers that you are inputting into the function. The domain represents the independent variable or the x values. The domain is listed as a discrete set of values as an inequality from least to greatest. And also under here put left to right. And we'll get into this in a minute. So when we define the domain, we're going to go from the left side of the x-axis to the right side of the x-axis. We're going to go from the smallest to the largest, and we're going to use that. We're going to use inequalities to define that. Y'all haven't done this yet, but it's a piece of cake. Now then, the range is the possible output values, right? So these are the numbers that your equation will equal to. The range represents the dependent variable, which is the word on the y-axis, or the y values. The range is listed as a discrete set of values or as an inequality from least to greatest again. Now then, think about the y-axis. The y-axis doesn't go left or right, it goes up and down, right? The least is down, the greatest is up. So when we read the range, we're going to go from down or from the bottom to the top. Let's put bottom to the top. So bottom to top. So the range is from the bottom to the top, the domain's from the left to the right. Now then we're just going to go through these. This is a piece of cake. We're going to define the domain and range given what's given to us in a table or ordered pairs or even or graph, okay? So on the first one, the domain and range for the vending machine function. Okay, so I'm going to assume this is your domain. This is kind of a bad example here, and this is your range. Okay, so the domain is the M&N, or let's just put set A. I'm not going to write all these out. And the range would be set B, right? Okay. Now then, let's just continue on. The domain, usually your domain's on the left, your range is on the right, okay? Jiminy crickets. Sorry about that. That zoom out. Okay. Let's go to the next part. Okay, now then we're on a table, right? Remember your domain is your x and your range is your y, right? Usually in a table the x is on top, the y is on the bottom. The domain here, remember you put braces and you go from the smallest to the largest, right? So -2, 0, 3, 6, 8. Your range, same thing. We're going to put a brace. We're going to go from the smallest to the largest, so we're going to put this backwards. We would go from the -9, -8, -4, 0, and 6, right? Remember, your domain and range, when you write it like this, does not match up. You're putting them from the smallest to the largest, and you're putting them in braces. Okay, this one would be a function because the x does not repeat, right? We did that last week. Okay, let's go through this one. Our smallest domain, and I'm just going to underline my x's here, would be -5, and then I have a -2, then a 0, and a 3. I'm putting them from left to right on the x-axis, aren't I? The range, put a brace, and it would go from the smallest to the largest. The smallest is -12, then I have a 0, then an 8, and then a 20. If we were on the y-axis, negative 12 would be on the bottom, and it would go up to 20 on the top, wouldn't it? And remember, these are discrete functions because they are not connected. They're only whole number values. You learned about discrete continuous in the last lesson. And let's go to number 3. Okay, our domain here would be your input. So your domain, usually in a mapping, is on the right. The range is on the domain's on the left. The range is on the right. So draw parentheses. Usually in a good mapping, they're in order. This one's not. Negative 4 is the smallest, negative 2, then 3, then 7. Remember, you're going from left to right, aren't you? Then the range, we're going to go from negative 8, negative 5, and 0. The range is going from bottom to top, right? Continuing on. Number 4, Susie is having a birthday party at her jumping zone. Oh, ho, ho. It costs $11 for each kid to jump. That would be your growing number, wouldn't it? Okay, her mom says she can invite a maximum of 4 kids. Make a table to show the cost of inviting 1 to 4 kids. Okay, so there is no starting number. So if you have 1 kid, it's going to cost $11. 2 kids would cost $22. 3 would cost $33. And 4 would cost $44. Okay, this also would be a discrete function, would it? You're never going to pay $15 in this, are you? It's going to go from 11 to 22 to 33 to 44. So our domain is going to be 1, 2, 3, and 4. And the range would be 11, 22, 33, and 44. Ho, 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 ho. Fun stuff. So on that problem, we didn't have, your function would be what? Y equals 11x. Okay, or f of x equals 11x. That would be your function there, right? And that we graph a line that goes to the origin. We'll learn about that later on. Let's go to the next page. So turn the page. Oh, oh, oh. Isn't this a blast, learning about domain and range? Oh, oh, oh. Let's keep going. When the domain and range of a function includes a continuous interval of numbers, then it will be written as an inequality. Describe the words on the number bottom below, then write down an inequality that represents it. This is how you're going to write this down. Let's write the inequality first. So the numbers go from left to right, correct? This is left, this is right. So we're going to go from the negative 4 to the 3. And it includes the negative 4, but not the 3, right? So we're going to put a less than or equal. And y'all have never done this before. And this is going to be our x-axis in it. This is how you write down a set of numbers. Goes from negative 4 and is less than 3. Okay, so we're going to start at the negative 4 and go to the negative 3, but not include it. So in words, you're going to write down, let's see how we write this down, a set of numbers greater than negative 4, greater than or equal to negative 4. This is going to be hard to write down in words here. Or equal to negative 4. And less than 3. Okay? So basically it's the numbers from negative 4 to 3, not including 3. Okay? And you're going to write that down. This is important. This is how you're going to write this down. So that would mean the numbers between negative 4 and 3. What if I wanted the range? I wouldn't put x there, I'll put y. And remember, the domain's left to right, the range is up to down. So let's keep going. Okay, the x and y axis can be thought of as a horizontal and a vertical coordinate grid. I hope that's what that's supposed to be. Find the domain from left to right on the x-axis. Find the range from bottom to top on the y-axis. This will make a little bit more sense here because we have an open and a closed dot here, okay? Jiminy crickets. Why is it doing that? Let me zoom out. Let me clear up. Hopefully this clears up for y'all. Oh. Okay, so our range. This is what I would do here. Okay? So, I can't zoom in or it's going to be like all boggled. But go to the bottom of the graph. Let's do the domain first. So the domain goes from left to right. So go to the left on the x-axis and put an open dot where that starts. Which is at the what? That's going to be negative 3. And then go all the way to the right and then put a closed dot right here, which is at 1, 2, 3, 4, 5. So do y'all understand that on the x-axis, that graph goes from negative 3 to 5. On the x-axis, it goes from negative 3 to 5 left to right. Now then, it does not include negative 3, so we put a less than, we put an x and a less than or equal. That's how you write down negative 3 to 5, but not including negative 3. Now then, on the y, we're going to go from the bottom to the top. So on the y-axis, we're going to put a dot right here and close it in, and that's going to be 1, 2, 3, 4, 5, 6. That's going to be negative 6 is my smallest y. Then go up to here, and that would be 2. So we're going to put y in the middle, less than or equal to, and less than, right? So the negative 6 would get a less than or equal to, and the 2 would just get a less than. That means that my y's could go from negative 6 to a positive 2, but not include 2. So that's how you write those out. You have never done this before. Remember, you always use less than symbols, and you just write it left to right, small number on the left, big number on the right. And if it has an open dot, you do not put the equal bar. This will get easy, I promise you. There's really no math. You're just writing down smallest to largest and using inequalities. So let's do the next one. Oh, the next one, there's 2 open dots, right? So we're going to have both open dots. I wish I could zoom in, or he won't be. Let me zoom in. Hopefully this will get clear on the video. Okay. Talk for a little bit. So on the domain, we're going to go from left to right. On the range, we're going to go bottom to top. So let's do number 5. Go from the left. It starts right here. Draw an open dot, and it goes to the 2. Draw an open dot. So my domain will go from negative 1 to 2 on it. So go down here and put negative 1 and 2. Then you're going to put your inequalities. You always use less than symbols. So I'm going to have a less than on the negative 1 because it's an open dot, and a less than on the negative 2 because it's an open dot, and I'm putting x down because I'm getting the domain. Ho, 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 ho. Left to right, always use less than symbols. If it's a closed dot, put an equal bar. Now then the range, we're going to go from the bottom to the top, aren't we? We're going to have 4 dots on our graph. 2 on the x-axis, 2 on the y-axis. The dots on the x-axis will be the domain. The dots on the y-axis will be the range. Ho, 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 ho. So let's keep going. And I'm going to do different colors for my domain. The bottom of the graph starts at the 0, and it goes up to 2, doesn't it? So my range, my y values will start at 0 and go to 2, put less than symbols, and we have a y, don't we? That's all you have to do. Piece of cake. Oh, ho, ho. So we're going to go to the next problem. Fun, 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 fun. Now then we're going to do domain and range again. We're going to make dots on the x-axis and on the y-axis, right? So the domain will start over here at negative 4, and I'm going to close the dot. And it's going to go all the way to positive 4, and I'm going to close the dot. So let's write down our domain. It starts at negative 4, it goes to positive 4, put less than symbols. Since they're closed dots, I need the equal bars, and we put the letter x in here. If we want the range, we'll put y. If we want the domain, we'll put x. Oh. Now then, look at the range. This is a flat line in it. The only y that will ever be is 6 in it. So the range is y equals 6. It will never get bigger than 6. It will never get smaller. It's just a horizontal line. This is a slope of a 0, right? A horizontal line. Let's continue on and go to number 7. Remember, we're going to put 2 dots on the x-axis, 2 dots on the y-axis. So our first dot on the x-axis would be right here, and it's going to be open at the negative 5, right? Then we're going to drop down, put a closed dot on the 15. Now then go down and write down the numbers. Our domain starts at negative 5, and it goes to 15. Put less than symbols. And now then, which one needs an equal sign? The negative 5 is open, but the 15 is closed. Close the dot and put the letter x in. That's how you write down the domains between negative 5 and 15. Oh, oh, oh. Let's continue on. The range. Okay, so we're going to put a open dot at the negative 10 and a closed dot at the 20, won't we? So the range will go from negative 10 to 20. So put negative 10 to 20. Put less than symbols. The negative 10 stays no bar, but the 20 is closed, put a bar. and then we're going to put the letter Y for the range. Oh. Fun stuff. F-U-N, fun. Oh. Let's continue on. Now then on this one, this is not continuous, it's discrete. So we're just going to write down the numbers. We're not going to use the inequalities here because it's not continuous. It does not include them all. Will the domain and range of this function be an inequality or a set of values? It will be a set of values. The reason the function is discrete. Okay, so basically, let's write down our domain. For parentheses, it's going to be -5, -2, 0, 2, and 4, right? So -5, -2, 0, 2, and 4. And the range, put them on the dots on the y-axis, right? We'll start at -5, -3, -2, -1, and 0. So -5, -3, -2, -1, and 0. So I just wrote down my domain and range. These would be the ordered pairs. Your x's are your domain, your range are your y's. So if you have a solid line, you will use inequalities. If you have dots, you'll just write down the numbers as a set of numbers. Let's continue on. And I think the next page is your homework. Okay? So the next page is your homework. I'm going to go back and show you how to do that in a minute. Remember, what did you learn today? You learned how to define the domain and range with inequalities. Okay? The domain goes from left to right. The range goes from top to bottom. Let me turn this off. Okay? So your domain goes from left to right. Your range goes from bottom to top. If you have an open dot, it's just a less than symbol. If the dot's closed, it's less than or equal. Piece of cake. This is not that difficult. So you are just defining what the domain and range is in this lesson with inequalities. Remember, you are amazing. You are created to do wonderful things. And from now on, I would like to end my lesson with a moment of Zen. So you're going to get 17 seconds of Zen every lesson from Mr. Toops. I hope you enjoy this. And remember, you are awesome.